Okay, today we're going to start section 8.5, which is using properties of trapezoids and kites. First of all, what is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay. Base angles, a trapezoid is a quadrilateral with exactly one pair of parallel sides. The other two sides cannot be parallel for it to be a trapezoid. Only one pair. The parallel sides are the bases. So I have a base, even though it's the top, and a base. The base angles, a trapezoid has two pairs of base angles. Base angles and the legs. The non-parallel sides are the legs of the trapezoid. And I have two legs. Let's see. Our pairs of base angles will be, this is a pair of base angles, and this is the other pair of base angles. Okay, our first example, using a coordinate plane, show that ORST is a trapezoid. So I see the two sides of the quadrilateral that I think may be parallel, because remember the definition of a trapezoid has exactly one pair of parallel sides. So I'm going to look at the slope of RS and OT. Okay, and I'm just going to count it. The slope of RS is rise 1 over run 2. And the slope of OT is 1, 2, 3, 4, which simplifies to 1 over 2. The slopes are equal. So RS is in fact parallel to OT. The other sides should not be parallel. So RO and ST are not parallel. Because remember, exactly one pair. So I'm going to do the slope of that one really quick. The slope of RO is, it is a vertical line, so it is undefined. And the slope of ST is rise of -2, +2. So those slopes are not equal, therefore they are not parallel. And we just did it. You try. What if, in example 1, suppose the coordinates of point S are 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. What type of quadrilateral is ORST? Explain. Okay, so I'm going to push pause and you guys can work on that one. Okay, I did the slope of all the opposite sides and found that they were equal. The slopes of the opposite sides are equal, so the opposite sides are both parallel. Both pairs of opposite sides are parallel. Therefore, therefore ORST is a parallelogram. You try. In example 1, which of the interior angles of quadrilateral ORST are supplementary angles? Explain your reasoning. I'm going to push pause and you can try to think about it before you look at the answer. Okay, I extended all the sides of the quadrilateral. So RS, I made the red line. It's parallel to OT, which is also a red line, and then the black lines are transversals. So I was able to mark the consecutive angles, and you have to remember from earlier this year that consecutive angles are supplementary because you can add them up to be 180 degrees. Okay, next, isosceles trapezoid. If the legs of the trapezoid are congruent, then the trapezoid is an isosceles trapezoid. Sketch one out here. Okay, we know that the bases are parallel. If the legs are congruent, it's an isosceles trapezoid. So let's look at the theorems associated with this. Theorem 814, if a trapezoid is isosceles, then the pair of base angles are congruent. Trapezoid ABCD is isosceles, so I have A and D are congruent, and B and C are congruent. We also just learned that A plus B is 180, and C plus D is 180. Theorem 815, if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So if A and D are congruent, then you can say AB and CD are congruent. You can also say if B and C are congruent, then AB and CD are congruent, and it's an isosceles trapezoid. Theorem 816. A trapezoid is isosceles if and only if its diagonals are congruent. So you can measure the diagonals, and if they're equal, then it's an isosceles trapezoid. Let's do an example. Arch. The stone above the arch in the diagram is an isosceles trapezoid. Find the measure of angle K, the measure of angle M, and the measure of angle J. Well, if it's an isosceles trapezoid, then the base angles are equal. So the measure of angle K equals the measure of angle L. And then we also know that K plus J is 180. So angle K plus angle J equals 180. So let's substitute in what we know. Subtract 85 from both sides. And we have angle J equals 95 degrees. J and M are a base angle of an isosceles trapezoid, so we also have the measure of angle M, which is 95 degrees. And you could double check by adding them all together, 85 plus 85 plus 95 plus 95, and you would get 360, which is the sum of interior angles for a quadrilateral. Very cool. Next, midsegments. The midsegment of a trapezoid is the segment that connects the midpoints of its legs. So if I have a trapezoid, and a midsegment's going to bisect each leg. These are parallel. This right here is my midsegment. And there's a theorem associated with it, of course. Theorem 817, midsegment theorem for trapezoids. The midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So this midsegment is also parallel to the top and the bottom, or the base, and its length is 1/2 the sum of the lengths of the bases. So we are actually going to use this for this lesson. The length of MN, the measurement of MN, is 1/2 AB plus DC, or CD. Let's try one. In the diagram, MN is the midsegment of trapezoid PQRS. Find MN. So we know that MN equals 1/2 PQ plus SR, or 1/2 12 plus 28. 12 plus 28 is 30, 40. 1/2 of 40 is 20. We have the length of MN. You try. In exercises 3 and 4, use the diagram of trapezoid EFGH. All right. If EG going to mark it, is congruent to FH. Is the trapezoid EFGH or is it isosceles? If I look at theorem 816, it says a trapezoid is isosceles if and only if its diagonals are congruent. Yes, because theorem 816. Number 4, if the measurement of angle HEF, it's this whole one right here, is 70, and the measurement of FGH, that one right there is 110, is trapezoid EFGH isosceles? Explain. All right, if, sorry, we can't, there we go. If we know the measurement of this angle, then we can say, I'm just going to name it angle E plus angle H, this whole angle, should equal 180. If E is 70, then angle H is 110. And angle H is now congruent to angle G. Angle H is congruent to angle G. If this angle is 110, angle G plus angle F should also equal 180 because they're supplementary. So let's substitute 110 in and solve for angle F. So now we can see that those are congruent. So by using what we know about trapezoids, we can say that the base angles are congruent, and yes, it's isosceles because of theorem 814. Okay, you try. In trapezoid JKLM, angle J and angle M are right angles. Well, I certainly didn't draw that right. That's an L. Whoops. Let's erase this one. Angle J and angle M are right angles, and JK equals 9 centimeters. The length of the midsegment NP of the trapezoid is 12 centimeters. Sketch JKLM and find its midsegment. Okay, we're going to sketch this one more time. That looks a little better. More like a trapezoid, less like a rectangle. Okay, the midsegment is 12, and JK is 9. Ha! I'm doing awesome here. I hope you guys are learning. JKLM. These are both 90, which means that these are both parallel. And JK is 9. Well, you can see from the drawing that if JK is 9, then ML is way out of proportion. JK is 9 and JKLM. I love erasers. Okay, my drawing is finally done. So let's find ML. So we know that the midsegment is 1/2 the sum of the bases. So 12 is 1/2 9 plus ML. First I need to multiply both sides by 2 to get rid of the 1/2. And then we can say that 24 equals 9 plus ML. Subtract 9 from both sides, and ML is 15. Hardest part about that one was drawing it, right? Okay, last part of the lesson, a kite. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So if I sketch out a very basic kite, we can say that 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So consecutive congruent, consecutive is one right after another, consecutive congruent, but opposite sides are not congruent. Theorem 818, if a quadrilateral is a kite, then its diagonals are perpendicular. Theorem 819, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Okay, these angles right there. If quadrilateral is a kite, BC is congruent to BA, and angle A and angle C are congruent, but angle B and angle D are not congruent. Find the measure of angle D in the kite shown at the right. Okay, this is still a quadrilateral, so the sum of the interior angles is 360. We know that if these 2 angles are not congruent, then these 2 angles are congruent. So we can say, all right, I'm going to name that X and that X. So if we add them all together, I would have X plus 124 plus 80 equals 360. X plus X is 2X. Let's solve for X. Subtract 204, subtract 204. 651, divide by 2. X equals 78 degrees. So each angle is, oh goodness, I've messed up somewhere. Oh no, this one's different than the one in the book. I think I'm good. Hold on a second. Math has been double checked. We are good. Okay, you try. In a kite, the measures of the angles are 3x, 75, 90, and 120. Find the value of x. What are the measures of the angles that are congruent? Okay, I do know that if I add them all up, I'm going to set it equal to 360. For sake of time, I have 285 equals 360. 3x equals 75. X equals 25. So that's the value of x. I see 3x equals 75. So I think those are my matching angles. If I have 75 here and 75 there, and then 90 and 120. Okay, those are the congruent ones where that's 3x, x equals 25, and we're done. Ooh, daily homework quiz. 3 slides. Number 1, number 2, number 3. Excellent work.